Right then, welcome back to the production line developer blog video things. I am going to load it in my recent game, that one. I am Cliff. I am the programmer and designer of this game production line, currently on sale actually in the Steam sale. Still in early access though. So I'm going to talk about what I've been doing in the last week since I last did a video. Basically there was a big bug that was fixed. I think it was fixed. I added some new battery stuff and I've done some optimizing. So we're going to talk about stuff in that order. So actually no, I'll talk about the bug in a minute. I'll talk about the new stuff first. So we have some new things. If I go here and I go to chassis assemble, which is where you get a fuel tank. Aha! Fuel tanks are only for normal cars, not for electric cars. So you will either fit, if you've got a hybrid car, you fit a hybrid battery. If you've got an electric car, you'll fit a battery pack or a large battery pack. And we now have all these extra things here: make battery cell, make battery module, make large battery pack, and make small battery pack. So these are all new things that you need to research, and you will find them, I think, under processes. Yes. So we have 4 new researchable things here. Now, if you're not as boring as me, and you're therefore not as kind of interested in electric car batteries, some people are really interested in it. Anyway, basically, you make little batteries that look like this, that are quite small. I think 2170 is the current one. Is that 21 millimeters by 70? Or that doesn't sound right. I'm not sure. Anyway, you make tiny little battery things. You put lots of them into a module like this. You can see like the little grid pattern of all of them there in the battery module. Then you put a number of battery modules. In the real world, it's often kind of like 8 or something into a large long-range electric car. We're not quite doing that. We're having, I think it's 2 of these go into a small battery and 3 of them go into a large battery. Purely because otherwise it doesn't really make sense with the rest of the game in terms of how many resources get sort of flung about. And these researchable things, they're quite difficult to research. They've got quite a high research point count there, especially battery cells. Battery cells is the really kind of like bottom of the chain thing, where you take, in this case, lithium, cobalt and nickel, and you make a battery cell. Obviously in the real world it's not as simple as that, because you'd also need some metal, and I think they have a kind of, it almost looks like Velcro thing that they put in there as well. Anyway, it doesn't matter. So we now have 4 new things that you can research later in the game. That gets you these new things here, and you can place them down. Now, I don't have final graphics for this. What I do have is I have the resource graphics, and a few other little bits. So these sort of bags here, kind of like large sort of plastic sack things, contain cobalt, nickel and lithium. You can probably guess that cobalt is blue, hence the colour cobalt blue. Lithium is white, and nickel is green, all as a kind of like little powder. So you import all of this stuff and you can combine it into making battery cells. So this is all placeholder because I haven't done it yet, because it's actually all in the wrong place. So you'll notice I've got like little workbenches here where we're assembling battery modules. That's in the wrong place because this is my battery module. I need to fix this. I need to fix this because we're getting a new machine in that will kind of like do this. So in the meantime, we've got like placeholder graphics here. I've got 4 of these making battery cells, and you'll notice we've got new robots, yellow robots. They don't animate yet, but they will do. So these resources come in, and out of that, you'll see it happen there. They export these battery cells. Ta-da! And they make 2 of them at a time. So you bring in 4 items and you get 2 battery cells out. The battery modules only require 2 battery cells. In the real world, there'd be hundreds, at least. But again, it's just an iconic representation. So you have this other facility here, well, not facility, slot, make battery module. and that takes in the cells and it exports these battery modules. The battery modules then go into making small battery packs or large battery packs. So this is the large battery pack thing. Again, it's pretty placeholder. So it takes a certain number of battery modules. I think it's 3 in this case to make a large battery one. Yeah, 3 and 1 chip, and out comes a battery pack, which is effectively a fuel tank for an electric car. Okay, why does it have a chip? Because modern car batteries for electric cars, they have a lot of circuitry in them. They're not just like a battery that goes in your phone or a battery that goes in a laptop. They're big, and they have a lot of circuitry in them that controls the rate at which they charge and the rate at which they like release energy and all kinds of stuff like this. I drive an electric car, and I do get a bit infuriated when people say, "Oh, don't buy an electric car, the battery will be dead in a few years." No, it will not. It is not a laptop battery. It's much more sophisticated than that. Anyway, whatever. And I've had my car 2.5 years and the battery's perfect. Anyway, so this is all new stuff. This is all new stuff, right? So what that means is when we come to fit fuel tank, which maybe I should rename to fit fuel tank or battery or something. Anyway, you can see here I've got a lot of electric cars and hybrid cars going through at the moment. So I'm not even bothering with any fuel here. And what I would do here, large battery pack, I think I'll go prefer local. And I would do that so that where possible I'm always using these, and I'm not importing things that I can make myself, because that should be the efficient way to do things. Okay, that's one thing. I'm going to talk about that. Now I'm going to talk about the optimizations and animation stuff that has changed. And then I'm going to talk about this big bug fix, and I'll have to show you another factory for that. So it turns out that if you create a custom map that is as big as the biggest map you can create, and you just fill it with available space, you research everything and you spend hundreds of hours on the game, and you build an amazingly huge factory, it will start taking up a fair amount of RAM. This is going to be all like fairly technical, so you can skip this if you're not into programming or how computers work right now. What a lot of people would say is it doesn't matter because everyone has 8 GB of RAM or 16 GB of RAM. I think I've got 16, I don't even know. It's not as simple as that. It's not as simple as that, firstly because you don't have 16 GB of RAM. Windows is going to be using some of it. Right now, if I launch Task Manager, blah blah blah, I can tell you that this game is using 598 megs of RAM at the moment, and Visual Studio, which is in the background but not doing anything, well, actually a little bit, that's using 640 meg of RAM. OBS, which I use to record these videos, is using 459 meg of RAM. Firefox, because it is incredibly sloppy, is using 1400 megabytes of RAM. So I'm actually using up 43% of my memory now, and I'm not really pushing it to any great extent. And I have a pretty damn good PC, you know, by the sort of average standards. Like Microsoft Photos.exe is using 164 meg of RAM. I don't even know what that is, let alone do I not use it. Cortana, which I've never used in my life, is using 56 meg of RAM. Anyway, the point I'm getting at is that RAM gets used up. And not only that, not everyone has loads of RAM, and I want to be able to make a game that will run very happily on your laptop while you're on a train or a bus, or maybe, you know, you do most of your gaming on a laptop, and what's wrong with that? And maybe you've only got 4 gig of RAM, or at the most 8 gig of RAM. So, you know, so for that reason, you know, I don't want to use up any more memory than I have to. But there's another reason for that, in that I would like to be able to build really big factories. I'll show you a bigger factory in a minute. This is a fairly big factory. I've been playing this game a long time. But I would like to be able to quadruple that. So any optimization I do now, and because I recently knocked about 100 meg off the usage of a large map, that will translate to like 400 meg knocked off the memory that's used for a big map. Anyway, so like, how did I do that? How did I save loads of memory? Well, there were a lot of little things. For example, people use integers in programming, which is basically a number that is a whole number. Basically, an integer is a whole number. So 1.3 is not an integer. 1 is an integer. 550,000 is an integer. And they tend to use a data type called an integer to store things like where is this tile in the world? What is its X and Y position? Is it 123 or 146.11 or whatever? And what most programmers would do, and what you would get used to doing, is using an integer to do that. But actually you can use something called a short integer, which uses less memory. Now, if you know that you're not going to have more than like, I can't remember what it is, 65,000 tiles in this direction, 65,000 in that direction. In other words, if you know that number is going to be pretty small, it's never going to go above a certain value, then you can use less memory for it. And I've gone through and found a few places where I was using large numbers where I could have used numbers that were half that size. It sounds like, oh, you only saved 4 bytes or 2 bytes there. But when you've got a lot of them, for example, these little objects moving along here, these little paint tins, they're called resource objects. These are resource objects here. There's lots of them, lots of them, lots of them. And they store their current position in certain circumstances as an integer. But it's their current position in this grid, which will only ever be 16. It will never be higher than 16. Even if I restrict it to never being higher than 256, you know, I can save loads of RAM. So I did some stuff like that, but I actually did some more interesting stuff to do with animation. So if you look at an animated robot, there you go, you see this animation. Here we go, it will fire again, I hope, depending. It's just typical, isn't it? Here we go, do some stuff. Oh no, that doesn't need anything. It's typical, isn't it? Typical. Oh, I specifically need robot animation. Where is, I'll make a complete kind of, oh here we go, this will be busy over here. But, so I'll just leave it open on these robots and hopefully they'll actually do something. Have I broken it? Have I broken it? Have I actually, oh, there is an ongoing bug with this that they don't always animate correctly. Anyway, right, it doesn't matter. The animations for these are not 3D objects, right? So there is not a conventional animation you'd get like in a 3D game. It is a series of 2D images, and each cycle of an animation is about a second long, and we run for 60 frames a second. So each robot at each angle has like 60 images. Now the trouble is, you end up with a hell of an amount of video RAM, texture memory, being used up if all of the animations, because there's several different types of robots and they've got these animations. Also these little people who are like checking clipboards and stuff like that. Oh, that's a little glitch there. And like adjusting their helmet, or like, you know, pressing buttons or whatever it is that they do. All of those little animations all over the place. If you just leave the images as they are, like a flipbook, which is how people tend to learn this sort of programming, it uses up too much RAM. So rather than just drawing a sprite and then drawing the next sprite and then drawing the next sprite, I think I broke it. Oh no, they're waiting for resources. Silly me. No, see, that isn't. I must fix that, you know. Anyway, so rather than just playing it as a flipbook, what I do is I take all of those images and I split them into 64 different sections, and then I create this like compressed version that only updates the bits that need updating. So like the bottom of a robot doesn't move that much when the robot actually animates. So it's typical that when I go to talk about animated robots, I've come across some sort of glitch where they won't animate. It's just so typical, isn't it? Here you go, do your thing. Here we go. So like little bits in the corner won't animate. So anyway, you end up with a really compressed animation that saves a lot of RAM. It saves a lot of video RAM, which is pretty damn important. So But the downside of that is each one of these, each little sprite like that has actually 64 images being drawn, and they're all drawn very, very accurately together, so it looks like it's just one picture, but they're not. And that compression works really well, and I couldn't make a game with this amount of variety in it without doing that. So the problem is you then have every single animatable object in the game, like a robot or a person, has 64 images, and each image has 4 vertices, which are kind of points, and those points have all these variables about them. Now if we really zoom out, you'll notice that I don't draw any of them. Do not draw any of them at all. It's only when we zoom in we start drawing the robots. If you keep an eye on these robots, which are animating, thank you team. If I zoom out to there, you can still see them, still see them, still see them, still see them. They're gone, I think. Yeah. So what that means is I can't draw all of them at once. Can't be done, I can't draw all of them at once. The GPU would collapse if I tried to anyway, right? So I've got all of this data for all of these sprites, and I'm not drawing them, which is silly. So what I do now is I have a kind of like central database of sprites when I need them, and when this robot works out I'm on screen, I need to be drawn now, it will get an index into that kind of like cache of sprites and say I'll use these sprites this frame, and then that one will say I'll use these sprites, and there's a limit. I think it's 1024 at the moment, don't ask why 24. So if you have a really big factory, then like 3/4 or maybe even like 90% of the memory that would be used to place all of these sprites just doesn't exist unless you're looking at it, which is the clue to optimizing all computer games. Ideally, if the player can't see it, it doesn't exist and you simulate it in some way. Anyway, and that saves hundreds and hundreds of megabytes, so I'm very pleased with that. I am now going to talk about the bug that I fixed, so I'm going to load in. I'm actually going to quit the game and relaunch it because I'm paranoid. I'm going to load in a much bigger map, and I'm going to talk about a change that I made. That was before I did all this animation. What am I doing? What are you doing, Cliff? Stressed through overwork. Look, I haven't shaved. You can tell. You know, I've got time to optimize, but not shave. What am I doing? This is my go-to stupidly big factory. Although I want this to not be stupidly big. I want this to be normal, like allow people to have massive factories. So loading this, the map uses 139 mega RAM. The slots, the production slots doing the work, they use 246 mega RAM. Vehicles use 295 mega RAM, and some other bits and bobs use the rest, but not a lot. So like all of the resource objects, like those little bits moving around the map, for example, they use 17 mega RAM in total, which isn't too bad at all, is it? So I'm going to show you this map because it was kind of broken. It's big. It was kind of broken in that it was stuck and things couldn't progress. And where it got stuck, and it's not stuck anymore, it's gradually coming back to life, was here. At the vast array of oh, hang on, it was bumpers, wasn't it? I think it was bumpers. Was it bumpers? Where's bumpers? Oh, here we go. Yeah, this basically wasn't working. They weren't getting resources coming in, so nothing could happen. And it's kind of clogged up, but it's unclogging now because of changes I made to the code. There's kind of like a backlog of stuff, so it's going to look less efficient than it actually is. Now what this came down to is that when you make stuff like bumpers, the output from this, it takes in one sheet of steel and it outputs 2 front bumpers and 2 rear bumpers. And the trouble is, if you output 2 bumpers and 2 front bumpers and 2 rear bumpers, and then someone uses the 2 front bumpers, all you've got left in your stockpile is 2 rear bumpers. If you do the same thing again and it happens again, you end up with 4 rear bumpers, then you end up with 6, then 8, and in the end you end up with 16 rear bumpers in your export, and you can't produce any more front bumpers. If somewhere else you had said, well, I only want to use locally produced front bumpers, which I know I'm producing, but I don't care where I get my rear bumpers from, you would get in one hell of a mess. Now, That would normally be fixed by stockpiles, and this player has in fact done that. They've got stockpiles that would allow you to take some of those excess bumpers from there into a stockpile and everything will be sorted out. However, stockpiles were broken. They were broken in the sense that a stockpile would go through its list of stuff that it wanted, and it would go through that list. So if we look here, oh hang on, where's the supply stockpile? So here it would say I want 18 rear bumpers and 18 front bumpers. So what used to happen is the stockpile would go, I would like 18, do I have 18 rear bumpers? And if it didn't, it would go, right, request some rear bumpers. If none were available because of the problem that I just described, that would be it. Then the next process tick would come around and it would go, do I have enough rear bumpers? And it would never get enough rear bumpers, so it would never even look at front bumpers, because it would only ever look at the first item that was unfulfilled in the queue. It doesn't do that anymore. Now stockpiles work more sensibly. They go through every item that they need and go, do we have enough of these? If not, order them. So if you have congestion at one point, it won't cause congestion in other points. If that doesn't make sense, I understand, because it took me days of staring at code to work it out. But anyway, it's fixed now. It's fixed now. Anyway, this is a longer video than normal because I rambled on about technical stuff, which you're probably not interested in. Anyway, this cool game is Production Line. It's about building a car factory. We're still working on it. There's some discussion now about putting in like high performance engines and stuff like that. I'm currently waiting for some more graphics to go in for various things. All of these robots are working quite happily. I don't know. Anyway, whatever. This is Production Line. It's in early access. It's currently on sale actually in the Steam summer sale. So if you've been watching these videos and thinking, oh, I'll get it at some point, you should probably get it now. Although I shouldn't say that, because if you really want the game and you want to support indie game development, and you want me to be able to afford razors to shave, then obviously you should wait until the sale ends, and then you should buy it full price, or you should buy it direct from us from our website where we get all the money, and it's best for us anyway. Do check out our new forums that we got. That kind of cool and have all these cool features and stuff like that. I hope you like this video. I hope I didn't ramble on too much about the technical side of things, and I hope it was, you know, vaguely interesting. Now you might think the game's frozen. It hasn't. It's just this is a big game. This is a big game, and it's saving. I just have to point that out so no one says. I should pop up a thing, but normally games, you know, they're normally not that big, and I normally don't have like streaming going on. Oh, marketing campaign finished. Excellent. Oh yeah, I added a thing. Shit, I added a thing. Look, this here. When it says insufficient resources, it now shows you. It actually shows you what resources are insufficient. Look, there, we've run out of light bulbs and sensors. Makes a big difference. Anyway, thank you for watching. Please subscribe. Blah 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 blah. Needy appeals to reviews and social media validation. Thanks for watching. We'll see you next week. Bye.